I'm Bill and I'm glad you're here. Let's take a look at the two kinds of electric flow. One is called direct current, which is what we've been working with in our battery here in our circuit, and the other one is called alternating current. You may have heard of them as AC and DC. DC is direct current. Like these batteries have a positive end, a negative end. We have a red wire and a black wire to help us remember which one is positive and negative. And the electric current is always going in the same direction through the circuit. But there is another form of electricity which is used for many things, and we will get to know it. It's called alternating current, and you might think of it as somebody who's very, very fast switching the batteries back and forth many, many times every second. Obviously, nobody can move that fast, but that's the way alternating current really works. This, don't worry about the innards right now. We'll get into that in a future time, but this, in place of the battery, is taking household electricity and giving me alternating current, the same voltage that the battery had, but it's not just going in one direction. And I used two yellow colored clips here to help me remember that there's no positive or negative to this because it's going back and forth and back and forth. Now the bulb still lights up and many things are the same. It's still making light, it's still making heat. There's still a number of amps of current flow and a resistance in the bulb. But the thing to remember about alternating current, or AC, is that it's going back and forth and back and forth and back and forth and back and forth, where DC is always going the same way. Now, we're going to take a look at one other thing having to do with this, which is our voltmeter has a place where we can measure volts and a place where we can measure amps, and we've looked at those. But if you take a closer look now, you'll see that there are two of these red V's. One of them has some straight lines and one of them has a wavy line. And same thing over here, if we were going to be measuring the amps or milliamps of current, there's an A that has straight lines and an A that has a wavy line. And the reason for that is the straight lines mean the meter is looking for DC, direct current, like batteries. And the wavy line means the meter is looking for alternating current, or AC. And your meter may be different from this one in many ways, but it will have a way to measure DC voltage. It will have a way to measure AC voltage, DC current, AC current. You'll notice that the resistance with this Greek omega here in the green, that doesn't have an AC or a DC because resistance is resistance whether electricity is going this way or that way or both. But as I turn the meter on, you'll notice that it has that same symbol of a straight line and some dashed lines underneath it. And that means it's expecting to measure DC, or direct current, from a battery-like arrangement. But I can tell it, I want to measure AC, and then it shows me that wavy line, meaning it's ready to measure alternating current. So we'll get into that quite a bit more in the future as we look at various aspects, because AC and DC come into electrical situations many times and in many ways. But for now, the thing to remember, there are two forms. One is DC from a battery or something like a battery, and the electric flow is always going the same way. And the other is AC, or alternating current, where the electricity is changing direction, usually very fast, very fast. The one that I showed you is going back and forth 60 times every second. That's too fast for us to catch, but the electricity doesn't mind. And that is AC and DC. AstuteKidDotCom.